that. So as I mentioned, the IPCC provides some guidelines on this. So in Chapter 5 of the 2006 guidelines, there is what's called the time series consistency. And in this documentation, there's then a whole segment on data availability challenges and then techniques you can use in order to fill these. So we can share the link after the meeting if that would be useful as well. But if you also type in time series consistency IPCC into Google, you'll also get it. It'll pop up. It goes into more detail than we'll go into here, and it also goes into some of the mathematical basis if you need it. But a lot of the time, you don't necessarily need that. It's using a bit of common sense and then following the principles of the IPCC to try and ensure that whatever method you're employing, you feel confident in, and as long as you're transparent about that, then that's generally the most important element. But that reference is there if you should want to look into this in more detail. So the first thing that guidance covers is that there are two main issues why we might have data availability. So the first is that we would have periodic data. So data that's only collected on perhaps a regular basis, but it's not necessarily regular enough to coincide with the frequency with which we're reporting. Particularly for something like a BTR, when this is being reported every 2 years, you might have data that's being reported every 5 years or so, or even longer, and so therefore, obviously, there might be challenges. There are a few issues that arise when you have these situations. So the estimates need to be updated each time new data becomes available. So your work that you're doing from a climate change perspective, obviously, as this new data as it becomes available, then you'll have to potentially go back and recalculate if new data has come available that sort of is significantly different from the data that you would use. And then obviously, if you're producing inventories for years after the last available data point and before new data are available, then you're going to need to employ a method. And so the method that the guidance references here is extrapolation, which we'll talk about in more detail soon, but I think it's possibly something that you might already be familiar with. And then, as it says, once your new data is available, you can then go back and recalculate it if there really is a significant difference between those two. The second situation is changes and gaps in data availability. So a change in data availability or a gap in data is different from this periodically available data because there's unlikely to be an opportunity to recalculate the estimate at a later date. So it's not just that, oh, the data will become available soon. We just need to wait, and then in a future compilation cycle, we'll be able to update that. There might genuinely be sort of a reason for this gap, and so you're going to have to employ a different measure in order to address this. So this you might also have a situation where in the future your ability to collect data will improve. So then you have higher tier methods that can be applied for recent years, but unfortunately you don't have those higher tier methods, the higher quality data for the earlier years. So especially where you've got situations like direct sampling and measurement. And so previously you might have had to make estimates, and now you've actually got direct sampling or measurements, and therefore there might be a significant difference between these two. So this is just something to be aware of, and you might need to apply one of the measures that we talk about in the future to that earlier data in order to get a consistent time series. Also, you might find that actually the availability of certain data decreases over time, and this can happen for a number of reasons. You could have changing priorities within governments. We've seen it here in the UK that governments, departments get defunded, and therefore their ability to collect data goes down. And so over time, you might have less availability of certain data points, and therefore you might need to employ a certain measure. Also, if you have an economy in transition, then you might have a very, very different definition and classification and level of aggregation than you did previously. So if you have significant changes in your economy, then obviously there might be data sets that are now not necessarily as applicable as they once were. So this is just to sort of think about, hopefully it will make you think about what are some of the situations where we perhaps don't have a certain data point or we're struggling to collect certain data. And also just to know that this is incredibly common. I'm quite confident in saying that this is universal, and so it's an opportunity. And then hopefully, later if people have queries, that other countries can also share their insights as well. But yes, So just some examples of data types. Obviously, this is going to be intuitive, but just to sort of get you thinking about where you might have different gaps. So you might have economic indicators, or you could call it demographic as well. So you can have your economic indicators, so things like GDP, unemployment, inflation. And then you might be collecting these from a domestic source. However, you might also need to look to an international source, because perhaps this data isn't available locally. And therefore, if you're looking to that international source, then there's a potential risk that there might be inconsistency in the time series, missing data for certain years, etc. With demographic data, things like population size, age distribution, urbanization, typically this will be collected nationally. However, obviously a census is only collected periodically because it's a huge effort on behalf of the departments conducting it. And also there are risks that it might be incomplete. There might be lack of granular data going down to the level that you need it. When there might also be international values available, but obviously they will likely have done modeling on the data, and so therefore there's going to be uncertainty associated with that. You have energy usage trends, so consumption by sector, renewable energy uptake, etc. So this might be available domestically, or you might be looking to an organisation like the IEA to try and get some overview. And the reason why in each of these instances we've referenced sort of a domestic agency and then an international agency is because this comes into play further down the line. This is related to some of the methods you might be able to use. So you might not be confident in a value you have. You might not even have an international value available, but there might be an international value available for a similar situation that you could perhaps employ in your situation. The issue here is that you might have insufficient granularity, or you might have underreported sectors. So certain sectors might be more data poor than others. You've also got things like changes in land use. This could include deforestation rates, urban expansion, general land use changes. Hopefully this is collected nationally. One moment. Or there will be potentially, because these things are often monitored using satellite imagery, these might be collected by international agencies with whom you can engage and potentially find some good data. However, there might be time lags because of the methodology used to collect this data, uncertainty in these measurement techniques, etc. Across these bottom two, I don't want to spend too much time on this, but so again, deforestation rates for environmental data. However, you've also got air and water quality. These might be thinking about the co-benefits of a measure, for instance, and it's kind of a similar challenge. Finally, some socioeconomic data. So this might be more like things like income levels, educational attainment, health indicators. So this might be, rather than for your mitigation targets, this might be for adaptation, and this might be available from your National Statistical Office or perhaps an organization like the World Bank. However, obviously the most vulnerable groups are going to be perhaps those that are least accessible, and therefore it might be difficult to get good data on these groups. So I promise we're going to get past these tables and lists soon, but just to talk about the different kind of data we have and the different applications of them. So on the left hand side here, you might be thinking about data that's required for developing your historical data. So perhaps you're doing your projections of your GHG emissions. For that, you'll need some kind of historical emissions often in order to project them. In doing so, there'll be data gaps around that you might need to fill. You then might look into the future, so you then have your projected data, and there also might be gaps. So for instance, an organization might say, we predict that the GDP will grow by this rate across these periods. However, that might not be available, and therefore you might have to make some assumptions. You've also got things like tracking data. So maybe you're tracking an indicator. However, not all of the data is available. Perhaps it's sporadically collected. You're also going to have situations where it's not even regularly collected, but in fact, there's maybe a study that was conducted at one point, and then you're going to have to use that study. And then so some of these methods that we'll talk about will be really, really useful. And then obviously those outputs can be used for any of those 3 points. And then just to look across some other different types of data that might be useful when you're thinking about projections, because you'll be thinking about growth rates, you'll be thinking about looking into the future. And these are all the different, these are potentially different types of data that you might need. And then also there's a sort of a qualitative assessment of how easy it is to collect this data. So things like population and the population growth should hopefully be quite easy. It's got a high ease of collection. However, something like structural effects, so if you have shifts from industry to service sector jobs, so you have significant employment changes, this might be quite difficult to collect, and therefore there'd be a fair amount of uncertainty. And I think this critically comes back to one of the principles underneath the IPCC, which is just transparency. So if we're clear about the assumptions we've used, then that's the most important thing. Because fundamentally there isn't really a wrong answer. It's just ensuring that the answer we provide is clearly documented. But yeah, I won't go through all of these, but you can see on the screen that there's various different data points that we might employ in our projections. And you can imagine the challenges in trying to get these values domestically, and therefore maybe start to think about some of the ways that you would try and address those challenges. And then before we get into the techniques, we're just going to briefly talk about the fact that we have different types of data. So obviously, as I mentioned, you'll have measured data. So this will be data that's collected fundamentally. So, and this could be something like emissions directly from a smokestack, or this could be, the population estimates, or for instance. So this is going to obviously have the highest reliability. However, it's going to be the most resource intensive to collect. So it's not going to be as common as perhaps other forms of data. You then have modeled data. So this is data that's derived from quantitative models. So this might be things like emissions from landfill or livestock. So where there's no way of going into a landfill stack and understanding exactly the emissions produced from the decomposition of that organic matter. That's not going to be possible. However, you can get a good idea and then hopefully model that data across the scale that you need it. Especially if you're looking across 10 years, then looking at how your waste collection might change, and therefore, based on those assumptions, how the emissions associated with that might change as well. You've got data calculated, so this will be just fundamentally obtained by multiplying activity data by an emissions factor, and obviously we've got uncertainty associated with both of those points. So we have our activity data, which we've discussed, but then the emissions factor as well. If we're using international defaults, then we're not going to have a gap, but we are going to have uncertainty associated with it. If we're trying to collect data for a nationally specific emissions factor, then obviously we have the same challenges associated potentially with those data gaps, where we might not be able to find all of the data we need, so we might need to employ some techniques. And then looking into the future, multiplying our projected number of vehicles by the emissions factor that we have. Obviously, there's a set of assumptions associated with that. So we don't know exactly the uptake of number of vehicles, and we don't know exactly how our emissions factor will change. So we're going to have to make some assumptions around that and then communicate those transparently. You then finally have sort of estimated data. So this is where proxy or alternative data sources are used to fill data gaps when more accurate or representative data is lacking. So we'll talk about this in more detail, but this is just to have you start thinking about different sources of your data. So you might be thinking that maybe you've got land use patterns in the area, but unfortunately you don't have an emissions factor for your specific region, but perhaps there are emissions factors available for a similar region. And so this is using a proxy or an alternative data source. And this is therefore estimated because you can't necessarily calculate it. You don't have that exact reference, but hopefully that gives you a good idea that you can communicate. So the first technique, there is a graph that can look off-putting, but really it's actually quite straightforward. So this is called the overlap method. And essentially, as long as you've got two data points that overlap, you can start to use this method to employ in order to address a data gap. So if you look at the graph, you have that blue line on the top. So that's a data source that you have a really consistent time series for. However, what you're trying to calculate is that pink line. And so that pink line with the squares, that's where you have good data for. However, you're missing all of those data points for that series from 1990 up until 1994. So you're trying to work out what these data points are. Well, thankfully, you have an overlap for all of these data points. Everything from 1995 to 2000, you have an overlap. And so what you can do is you can as it says up here, you can average the ratios of new to old. So the ratio of this data point, these data points, these data points, these data points, these data points, etc. You can average those, and then you can use that average then to determine the gap in between your data points going backwards as well. And so that's why this line is called your splice. That's where you've spliced your data. That's where you've used your overlap in order to fill a gap. And so you're using perhaps a new data collection method. However, you don't have historical data. So 1995, you started using your method. However, from before that, you don't have it. And so what the method is you create a consistent time series by aligning your older estimates with new method during years where data overlap. So you have that comparison. It's obviously really clear and quite transparent as well. And then you have a smooth transition to the new method without losing that historical continuity. So perhaps rather than maybe you were using this blue line, for instance, if, for example, maybe we were using the data here, and then if we were to have a change to a different method, there might be quite an abrupt change. So rather than using that, what we can do is use the overlap method and then regress and do that historical time series from that, and then hopefully therefore we can have that smooth time series and it's reliable calculation. And so adjust those original emissions estimates to align with the new method by averaging the ratios of new to old estimates during years where both data sets overlap. And as I said, all you need is at least 2 data points that overlap, so 1 data point in each data series. You've also got a surrogate method. So this is what we just spoke about, the idea of when we have, you can use what's called a proxy. So when direct data is unavailable, so we just don't have the data points. However, we know that we have a data point for something similar, that we feel confident that there is a significant enough correlation between these 2 data points that we could use this other method in order to fill this gap. So looking here, we have this dark blue line that's our data point that we're trying to pursue. And then we also have this pink line that we're aware of. So this pink line is coal production. We're very, very confident of that. We collect that measure. We measure that data regularly. We know exactly how much coal is produced. However, our measured emissions, they started in, 93, and therefore we're not exactly sure of what the emissions were before that. So what we can do is we can use exactly the trend that we saw in that coal production. We can apply that to our measured emissions and say, there's a good enough relationship between these two that my best estimate is going to be using that trend to apply it to the data point for which I do have a gap. Obviously, there's a tremendous amount of uncertainty. You can see that they don't follow each other exactly. However, if you were to average this trend, you can see that broadly they're heading in the same direction. So anomalies like this 93 value for your coal production or this 95 value for your measured emissions, we can sort of ignore those and say, actually, over time, our trend is similar enough. The third out of the 4 methods is interpolation. So this is one you're likely familiar with. So we have our blue line here. It's going along until 1992, and then there's a gap. We don't have a value for 93 through 96. What we do have are values for 7, 8, 9, and the year 2000. So what we can do is we can just draw a straight line between the data points. We do have a value for 1993, and we do have a value for 1996. So it's just these interpolated points here that we need to find a value for. So we can just draw a straight line between these 2 points and say, well, there's no way of us predicting exactly the variability that we would experience. So it's better that we just kind of understand the trend associated here and then draw a straight line between these. This is something, if you ever used the LEAP model, there are functions within that to do this directly in the data set. So it's really, really useful. So you don't have to calculate the trend yourself. The model itself will do it for you, which is really, really useful. And this is a very, very common method that you would use. So you might have a gap in your data series. This might be because of something like COVID, for instance. During COVID, you might not have had the data collection that you were used to because maybe your industries were shut down or for whatever reason, where you didn't have the department wasn't in work. So therefore, they weren't able to go out and collect the data. So obviously, we can interpolate between our missing data points. Finally, you have extrapolation. So this is where we've got a data up until a certain point, and then from there we need to determine what the next value will be. So this is particularly relevant for looking into the future. You might have a trend, and you're not exactly how the trend will continue. But what you can say is, okay, if we just assume that the current trend will continue, then we can extrapolate that data point. This is something that's very, very common, especially when you're doing projections. So you might not be able to know exactly what will happen in the future, but you can extrapolate from the data that you have. And then after that, so what this blue line is then you do have your actual periodic data. So later on, you've then collected your data point for the year 2005, and you've realized that, yes, it wasn't exactly what we saw. So you can go back and you can recalculate any emissions calculations that you did on the back of that. But what you can see is that it was a reasonable estimate to have used. Because you're using this average from all of these data points, you're going to avoid any real uncertainty. Obviously, you've got things like COVID, where there'll be an anomalous value. You'll have a value that's significantly different from the previous trend. That's going to be more challenging to use any of these methods. That really is. So that's where something like a proxy data set might be needed, because obviously it's going to be challenging to extrapolate a previous trend when we have a once in a generation event. So this is just a summary table of what I just explained. I'm not going to go through this. We've just explained it, but that's there as well if you want to review it later. And there are also some comments here that we sort of perhaps it's worth just covering briefly. So if you've got things like, so with our overlap method, that's where we do have a sort of an alignment where we do have two overlapping data sets. So it's most reliable when the overlap between two or more sets of annual estimates can be assessed. However, if the trends observed using the previously used and the new methods are inconsistent, so if you're seeing a massive difference between them, then obviously this approach is not going to be effective, because that ratio is going to be too inconsistent. If you average it and it makes it seem like, oh, that's fine, we've got a good value, but actually you're going to be adding a lot of uncertainty because of that variability year on year. So that's where an overlap method might not be applicable, and you might want to use something like extrapolation perhaps instead. If you think that your time series is relatively predictable, that your trend is relatively predictable. For your surrogate data set, you should ideally test multiple indicative data sets to determine the most strongly correlated. So you might have a value that you think is correlated, and actually when you test it, you think, that might not be the most accurate. Whereas if you compare others, so maybe you've used an industrial value and then actually you use population or GDP or something like that, and you think, actually that tracks it in the historical data that we do have, those two track each other quite closely. So perhaps that's a more appropriate value. It can be attractive to try and use the data sort of data set in the industry or the sector that we're using, but there could be variability there for reasons that we don't know. Although even if we do know, but it could be perhaps there's a better data set that we want to use. For interpolation, also the main thing with that surrogate data is ideally you should not do that for long periods, as obviously there could be there's going to be more variability. Your uncertainty is going to be higher the longer you do that process for. Obviously, if it's very, very close, almost identical throughout, then there's less risk there. But obviously, the longer you do it for, the higher the risk there will be of those trends starting to differ and that correlation being reduced. So the method, so when we're thinking about interpolation, so if we have large annual fluctuations, so this is what I said about using like something like COVID. If we've got really, really significant large annual fluctuations, then using those previous trends and showing that straight line between the two obviously isn't going to be appropriate necessarily. And so that might be something where using a surrogate data set, for instance, might be more appropriate. For your trend extrapolation, you shouldn't really do this for long periods. And also if you're seeing a significant change in your trend, so maybe you're seeing a decrease or an increase, for instance, and then you've just linearly extrapolated that, you're either going to be underestimating or overestimating what the possible future situation might be. And as you go further into the future, that difference from the actual value will become worse and worse and worse. Obviously, you need to do what you can. If it's the best value you have, then you're going to have to do what you need to do. But it's just something to be aware of and to be transparent about. And then just a final point, obviously just document your customized approaches thoroughly and compare results with your standing techniques. So if you're having to change things like if you've got technical conditions that are changing through the time series, e.g. mitigation is happening, then you might need to employ some other techniques in order to modify the ones you do have. So I'm just going to go through 3 examples that are broadly the same, but hopefully it will help you think about the process you would need to go through if you're doing this on your own data set, and then that'll be the end of the presented section of this session. So if you're thinking about the transport sector, you might be thinking about the availability of data for vehicle types, fuel consumptions, distance traveled annually, for instance. So the first step is to determine your data gaps. So the specific years, the vehicle types, or the fuel usage that you can't find. And then we can go through each technique and we can determine its applicability depending on the nature of the data gap. So if data are missing for initial years but available later, then perhaps we can use the overlap technique if there's that method change. Otherwise, it might be more appropriate to use trend extrapolation backwards to say that we can observe the trend as we've got with the measured data, and we can extrapolate that going into the past. If data are periodically available, then we might look for a surrogate data. So this would be things like perhaps we'll be able to gather fuel sales data. Maybe we don't have our vehicle type data, but maybe we can infer that based on the fuel sales. Obviously, if you've got significant diesel consumption and you know that consumption is associated mainly with heavy goods vehicles, maybe buses or lorries, for instance, then maybe you can use that to infer the ratio of your sales to the ratio of your vehicle types, etc. And then finally, you've got interpolation. It can be used if you have data points before and after the gap, assuming your stable trends. So as you said, just drawing a straight line between those two. And then you have for non-calendar year data. So this is quite interesting as well. So obviously, a lot of data will be collected on the same time period across your calendar year. However, there will be data sets that aren't collected. So you just need to adjust your collection periods here. So just sort of adjust your overlap to ensure that the data points that you are collecting for. So maybe you need to aggregate 2 different data sets. So particularly if the data points you're looking across are perhaps collected for a financial year, then you might need to aggregate 2 different data sets to ensure that your collection periods match each other for you if you're using calendar year for your other data point. Implement the technique, and then critically you want to validate and adjust it. So this is where surrogate indicators can actually be really, really useful. So you might have used any of these methods, but you then compare it against a surrogate just to see if what you've calculated is actually reasonable, or if there's something you've overlooked. And then adjust your methodology as necessary. So in the transport sector, this would be things like vehicle kilometers, fuel efficiency, vehicle type. And particularly in early years for certain vehicles or in or fuel efficiency data, there might be methodological changes. Maybe you have so in the UK we sort of have an MOT, so we have a log of every vehicle, its age, the distance it's traveled, etc. That's government collected. So maybe this is implemented in your country, so you have this data going forwards, but previous to that you don't. So that might be a situation where you need to use one of these techniques. So this is for the agriculture sector. So potentially you're like trying to find your livestock population, the feed type, the manure management practices. So you wanted to identify where you have missing data points for maybe specific livestock categories. Maybe you've got feed conversion efficiencies or manure management systems for certain years. So if your initial year's data are missing, like we spoke about, use the overlap technique or trend extrapolation, depending on the surrogate data you would use in this instance might be something like feed sales. It might be something like land use changes. And then similarly, interpolation would be used if you've got a big gap. And then the rest of the points here are the same as in our previous method, but it's just to give you an example of if you have a sector that you're particularly struggling with. So the data would include here the number of animals, the types of feed, the manure management practice, and you'd have those gaps in the early years or for specific livestock categories. Finally, if you have, for instance, a gap in your cement data, so this might be cement production volume, this might be fuel types used, this might be your emission factors, for instance, this might be the proportion of clinker in your cement production, and so you want to find your missing data. And then I won't repeat what we've just discussed, but your surrogate data here might be like an indicator, like the economic output of the construction sector, so the contribution to GDP perhaps. So this you can see if you're consistent with your cement production and its relationship with economic output of the sector, then that could be a really, really useful surrogate data set in order to fill any gaps. So yes, I think that is everything from me. So we can pause there. and open the conversation and hopefully, yeah, discuss with each other.
Yeah, thank you, Dominic, for even this condition. You are continuously speaking and the same energy that you have during the South Korea Seoul workshop. So I think this is your one of the hobby to teach everything in detail, not just to give the overview. Yeah, so we are really happy. So yes, participant, we are around 15 participants. So I would request, so if you have any question, any doubt related to data, because data is the main thing that depends and the main component for the inventory and the NDC tracking. And as Dominic said that now we have to not only in currently developing countries are not reporting as a usual practice to this time series reporting, but under the BTR now we have to report the time series data. So these techniques are most useful and it's a standard technique in the IPCC guideline. So we can of course take as much as advantage of it, and later on we can build our capacity, and when we are preparing the second or third BTR, we can move ahead to the more better and transparent data as much when we are build the capacity. So
That's an. Oh, sorry, Jaypal, please finish your thought.
no, please.
I think that's a really excellent point. I think what a really relevant thought there is that for our inventory compilation, obviously we have to compile for ideally 2 years before our reporting date, but 3 years at a maximum if you use flexibility. So that's 2021. That could be very, very challenging for a lot of countries. And so this is where we might not have data that is up to date on that. So that might be an example where you would have to use one of these methods perhaps. So in order to extrapolate or in order to use a surrogate or whatever it was. So yeah, just to say that's, and if anyone's got an example of that and they think actually, yeah, we've started this process, we've started that, we've done that, or this is a challenge we're faced, please do share, because I think we're all in the same boat when it comes to that.
Yeah, I think, and even it's not like when you submit the data, you can't change. There is also the one process of the recalculation. So it's not like that you made a mistake in the data and in the next BTR you can't change, but of course there is a possibility. And every time you can do a recalculation, whenever you have a more accurate, more transparent, more comparable data, you can just replace it. So don't consider that you have run once you run the data techniques that you can't change. You can change it anytime. This is your data, your country, and everyone has to read from your data, and you are the best expert for this data. So I think we are waiting for the question, but at that time I will also request everyone. So if you are comfortable to please turn on camera so we can take a one group photo. If you are not turning on your camera, then I have to take your photo from the South Korea workshop. Yeah, I can see the smiling faces.
And thank you all for joining. It's really good to see you, and even joining from a car. That is very impressive. I hope my presentation didn't make you travel sick, but yeah, thank you for joining.
Okay, if someone's still trying for the camera, I will wait few seconds and then I will take the first snapshot. I think Milan is here, but she is not comfortable, or maybe she is in the listening mode. Our organizer is. Okay, let me take the first picture. Okay, Darwin has some problem, no worries. Okay, I also see the raised hand from Mujidma. You can continue to ask question. The floor is open.
Okay, questions, I mean, picture taking is over. Okay, I just raised my question before. Okay, Dominic, just one thing, it was very interesting. The overlapping technique, you know, you said at least 2 points overlap. So that's very interesting actually. Of course, in the picture it was 4 or more points overlapping, but you said at least 2 can overlap, then we can interpolate the previous ones, right? So it's very interesting. It's not really a question, but is it? So for example, we have overlap for 4. In the picture it was 5 or something like that, I forgot. But can we choose only 2 of those, or we just choose all of them, whatever overlapping point we have, and then we can do it? Of course, it will be more accurate, I guess. And then okay, this is great techniques, and you already tell us which technique is good for which data, right? I mean, you've given some tips for us. So I'm just wondering if should we use the same technique for each time series, or we can choose the different. You said it already too. Okay, but I mean, just wondering, for one time series, for example, we can use overlap, and then we can use surrogate, and we can use extrapolation, and then we can choose the best one, or how it works. Oh, you already done that for us, and you already given us some tips. Anyways, thank you.
Thank you, Vijiba. Yeah, so on the first one, and I can try. Oh yeah, and I see we got a question as well. Yeah, do you want to come in and we'll ask a question? I'll answer them all.
Mohsina, please.
You're currently muted.
Yeah. Mohsina, you have to unmute your mic.
Right now, is it okay?
Yes,
okay,
yes, please.
Okay. I'm just requesting to give us the record, because Jaipal, you know, I was in meeting with the UNDP, and a little bit time I'm just engaged in this meeting, so that if you give me or share me the records, in that case I can understand this meeting's actual thing, and the next time if you organize another meeting, that time. So please share with us the record. Thank you. And thank you.
Yeah, thank you. Yeah, we will share the PPTs and the recordings.
Okay. I think Dominic is off right now.
Yeah, I think he's freeze or.
So meeting is done right now, or we'll continue.
There is a one mentee. Every time, we do the mentee whenever we meet. So there is only, I think, 5 minutes is left. Yeah.
Can
Dominic.
you hear me?
Okay. Okay.
Yes, Dominic, we can hear you.
I think some network problem.
Yeah, until we hear back from the Dominic, I have posted the link in the chat for the mentee, so you can complete at your convenience.
Now.
Yeah, Dominic, we can hear you now.
Oh my God.
Okay, until we hear back from the Dominic, I would request everyone to give your vote.
Okay.
Can you hear me now?
So where?
Yeah, we can hear you. Please. Now we can hear you.
Okay. Okay, J-Power, give me a thumbs up if you can still hear me. Okay, that was very strange. I could hear you perfectly throughout. Okay, so Bujiba, yes. So what we have is, if I go to the guidance, and sorry, I didn't say this clearly enough, but it's actually so this is in the time series consistency document. What you'll notice here, So a relationship between a previously used and new methods can be evaluated by comparing the overlap between only one set of annual estimates. So this is literally just one data point, but for your two data sets. So this is what I mean by 2 points. So actually, your point is really, really important. So essentially, as long as you have one ratio that you can find, you could in theory apply this method. However, obviously, it's preferable to compare multiple years because obviously there's a potential that it's going to lead to bias if you haven't got those multiple years with which you can compare. So it's a really, really important question. So ideally use as many years for that comparison as possible. So you would take the ratio between all of the data points and then average them and then apply that to your data set. So, but really, really important question. And then the second question about what technique is most applicable to which data set, completely up to you. As you say, within each data set, you might have different challenges. So for some data sets, a surrogate method might be available. For others, it's just not going to be available. So particularly things like in the industrial sector, economic data points are really, really valuable. So things like GDP often correlate very, very closely with industrial output. In other sectors, there's not necessarily going to be that same relationship. So you might need to interpolate or extrapolate for those other data sets, but a surrogate method might be more useful. So it's, as with everything here, just be transparent. You can always just clearly state the methods that you've used. And for each data point, you're just trying to find the method that you think is going to give you the most accurate estimate possible. But yeah, really, really, really good questions. Thank you.
Yeah, thank you, Dominic, and thank you, Mujid Ma, for the question. So the last request is that I have posted the link of Mentimeter in the chat. So please vote your answer. There are only 2-3 questions. One is about the feedback and one is about our workshop that is there any way you have used the knowledge that we have provided during the workshop, maybe in a BTR development or maybe some NDC tracking or maybe a tracking of some policy actions in the country, whatever area you are working. Let me also share this screen. Okay, so 6 of them are told that we have received 7 responses.
Sorry, Dominic, one more question.
Yeah, please.
Of course.
Oh, I forgot my question. Just a moment. Okay, so in your examples, all the missing data was before, like for example, some emissions is not calculated from 1990, but other examples show the one in the last. How about in the middle? How about in the middle? If some data missing, like 1 or 2 years data missing in middle, so we still can use both ends data or interpolate or overlap or whatever. Is it both is optimal to use, or just one side is still good to use to do that?
Great
Maybe
question.
The application will show everything, but I'm just wondering. Okay.
No, thank you. I think it's useful for everyone as well. So the guidance that we're using comes from an inventory compilation perspective. So the whole time they're just thinking about inventory compilation. So often they're thinking about a new method has been introduced for our historic emissions. So that's where a lot of the examples are looking backwards in time. However, as you say, there might be a gap in the middle, and this is where interpolation is a good idea. So that's one. If you feel that there's a strong trend between your two areas where you do have data, you can draw a straight line between them. If not, as you say, overlap could be particularly useful if you do have another data set, or a surrogate method could. So it's all of these methods are going to be applicable to all situations. The only difference there will be extrapolation. So extrapolation is only generally applied when you're looking perhaps into the future. You can extrapolate backwards. So essentially extrapolation just means you've got a whole data series and you're either going backwards from it or forwards from it. So this is where, particularly for projections, because obviously you're not going to have measured data for projections. You're not going to have measured data for 2030, 2040, 2050. So extrapolation is often going to be used. However, that doesn't mean these other techniques aren't relevant, because your statistical bureau might have projected GDP, but they haven't projected cement output, right? So you could therefore use that as a surrogate method, even though you're looking into the future. So you can use them for all situations, whether you've got a complete data series and you're looking forwards or backwards, whether you have a gap between two data series, as you're saying. All of the methods are applicable, and then it's important just to be transparent for which data points you actually have values for collected data, and for which values you've then modeled or interpolated, for instance. So that's just to be transparent and say, and for instance, we've done this before. If we have a line graph, and then we'll use a slightly different line. So maybe you have a solid line for the data points you do have, and then a dotted line for when you're sort of filling in the gaps. And this can be a nice clear way of showing that we don't have the data, but this is our best guess.
Okay, that's good. I mean, maybe I'm boring everyone, but just this methods can be used for the land use change in the land use and land use change forestry section. Especially, we don't have 20 years ago, the last 20 years average land use data. So it's like we have to use the 20 years, like it's called splicing, right? So anyways, I think this method one of these methods very good for that. Okay.
Absolutely.
I'm just thinking out. I'm sorry. Thank you.
No, absolutely. And you might find there also might be a proxy data set. So you might find that actually there's an area in the region that has a very, very similar land cover, very similar behaviors, and actually that they've got data for that data set for that time period. So you might be able to use that as an example, as a proxy data set. Or you might want to extrapolate or whatever it is. Yeah, it's exploring potentially multiple methods and seeing which method you think is most accurate.
Exactly. I think these methods, I have to learn more, I guess. Thank you.
Yeah.
Okay.
Of course.
Done.
Thank you, Bujima.
Okay. So if anyone has any question, please.
You gave a link for fulfill of this every gap. So we have to submit it today or right now.
Today you can submit, please. Yeah.
Okay. And one more thing, I'm just doing one training. You know very well the CBIT project, which is supported by the FAO. So first phase already finished, and second phase maybe will come. So after completed our CBIT first phase project, we need to do something which something or some work already undone. So one thing, it's EFT. You know EFT. So I will do this EFT related work in 2 days, and after doing this training, if I feel to discuss with you, is it possible to talk with you, because it's really neat if we feel some problem, so that we can take your opinion or Dominic suggestion, so that we can do it properly. Is it possible, Jaipal? Because
yes.
It's real. Yes. Though we have a
please
FAO,
drop a message anytime.
Yeah. So thank you. I will submit it I will provide it right now. Okay. Thank you. So for this reason, I'm doing. I use I use the knowledge which I achieved from your workshop in the South Korea. So I properly use this. Now I feel yes, I have to do regarding the NDC. And a few days ago, FAO organized 2 days program, and this is lead ministry was the Ministry of Fisheries and Livestock. So that day, I'm giving some suggestion from this workshop. And also, I did a workshop in the cabinet division, and cabinet division wanted to take the suggestion to incorporate the all the data or compile coordination, how they will coordinate every data from different ministries. I just suggested the NDC report, how the tracking or indicator will compile and prepare the report and send it to UNFCCC, and how Ministry of Environment, Forest and Climate Change or organize all the data. I just suggested, and I think this workshop really influenced me and helpful to give the suggestion every moment. Thank you.
Yeah.
Thank you for this training.
Yeah, thank
Brilliant.
you. And all the material will be trained by our expert Dominic. So we are
Yeah.
all
Yeah.
obliged to.
Hope again we will see in that type of a workshop or training.
Sure. Thank
Okay.
you.
Thank you.
Dominic?
Yeah, Ambika, please.
Yes.
Hello. Yeah, thank you very much for your presentation and description on the method. You have explained that for collection data. So I have a clarification. What are the practical and cost-efficient options for measurement and data provision, especially for proxy measures? Is it clear?
Sorry, my connection dropped out midway through that, Ambika. Could you say it again, please?
Yeah, I want to clarify from you that what are the practical and cost-efficient options for measurement and data provision, especially for proxy measures.
Okay, so the cost and yes. Okay, so which are the methods that are most cost and sort of resource efficient?
Yes.
Yes, yeah, it's a really good.
Yeah.
Yeah, so it's a really good question. And so the easiest are going to be extrapolation and interpolation, because they're generally, it's quite a straightforward process. You can do the calculation yourself. You don't need to do any additional research. Whereas obviously for surrogate and for overlap, you're going to need to find another data set, and you're going to need to review this. So you might have to inquire with another agency, another ministry, for instance, get their data. You might need to search online. You might need to do an additional other elements. But often interpolation and extrapolation come with the higher uncertainty, because you're making a very big assumption that your trend is going to continue exactly as it has done previously. I would say that interpolation and extrapolation are sort of like the most cost and resource efficient, but surrogate and overlap are going to take a little bit more work, but would give you potentially a bit more, maybe some more reliable data, but it's not guaranteed. And this is why it might be worth, so perhaps you do a surrogate, you look for a surrogate data set, but you also perhaps do interpolation or extrapolation as well, because they're quite easy to do. So therefore you can compare the two and you can see if there's any significant differences. So for instance, if there's a natural disaster, for instance, during the year you're collecting data for, maybe there's a massive difference in one of your data points, and if you interpolated, this wouldn't be picked up, but a surrogate data set or an overlap might pick this up.
Yeah, okay. Thank you.
Hopefully that was clear. And then please do, if you feel like it wasn't, you can always email us afterwards and we can have a chat as well.
Okay.
Okay, I think I can't see any raise hand or any unmute mic. So this is the now end of our today's webinar. And for the 2024, we are also doing the same kind of training. So our partner PATPA has also organized the training from 29th April to 3rd May in the Brussels, Belgium, for the BTR dialogue. And we have also organized the BTR training in the 28th May in the Japan. So the invitation was already sent to the UNFCCC focal point, and we are happy to see you again during these two workshops. And please if you are comfortable and convenient for this timing, please join this session. If you need any
And
more
this is also
information,
for Jaipal, this is also for 3 days only, the training?
yes. No,
3
actually,
days.
this is the 5 days training for the Patpa
Okay.
also, because they are covering the lots more content, and that Japan one we also, it is a 5 day. For the 2 days it is for the all the developing countries, not the region wise. So all the 150
Okay.
developing countries are at one place, and then there is a 3-day workshop about the inventory. So last year we have focused on the NDC tracking, but this year we are targeting the greenhouse gas inventory. So that's the target for
Okay.
this year.
Okay, so we yeah, if you just share with us, then so that we can inform to our
Sure.
secretary sir and do the
I will
nomination.
forward the
Yes.
invitation.
Yeah. Okay. Okay.
Thank you.
Thank you.
Okay, so thank you everyone. Thank you our friend Dominic to conduct this session, even this tough time, and also the very early morning in the UK. And we everyone can see his energy to teach everyone. So we are happy to see him again. And if we have opportunity in the next anytime, we will of course invited him again, and we will gather again for any kind of training or workshop or webinar. If you have any question, please feel free to ask or drop an email to us. So I will end this meeting today, and I will again thank you to everyone, all the participants.
Yeah, Dominic, thank you. Take care. You're good
Thank you,
thing. We're
Jaipal.
not in minus 20 degrees now.
Thank you, Jaipal. Thank
Good
you,
luck,
Dominic.
Majima. Thank you so much, everyone.
It's not getting warmer.
Thank you, everybody. Darji, Hajira, all
Thank
the
you.
Milan, Selema, everybody. Just tata bye bye. And happy Diwali.
Thank you. Bye.
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 Hajira, how are you?
I'm good. How are you?
I'm fine.
Nice to
Thank
see
you.
you
Bye bye.
online. Bye bye.
Yeah. Talk to me.
Bye.
Okay, Hajira.
Okay. Bye bye.
Bye bye.